Hello and welcome to Lesson 2, Intro to Derivatives, where we discuss about the limit definition of a derivative and what it conceptually means. So say you have this table right here, and you have x as your time in minutes and y as your distance in meters, and it follows x squared. The function is basically y equals x squared. And the goal is to find the instantaneous velocity at a specific time. And for our case, let's try to find what it is at x equals 3. So the way we can approach this is simply by using the slope formula we all know and love. So for example, let's take the interval 3 to 4. The slope of that would be 7. If we do 3 to 3.5, we would get 6.5. If we do 3 to 3.1, we get 6.1. If we do 3 to 3.01, we get 6.01. So you can see that the idea is that as we shorten the interval, we get more accurate results. So we need to get the interval to be as small as possible, and this is where the concept of limits comes in. So let me clear all of this. So let's say we have the following interval, 3 comma 3 plus h. And remember, the goal is to get h to approach 0 since we want the interval to be as small as possible. So as h approaches 0, the limit of, and what's going to be in this part is basically the slope formula. So you would do 3 plus h squared, and that's because remember the function we're working with is y equals x squared. So you just grab the 3 plus h and you put that into x squared. And then you do 3 squared. So this is your y2, this is your y1, and then simply 3 plus h minus 3, and this represents your x2 and x1. And this comes out to be 9 plus 6h plus h squared minus 9 over h, and that can be simplified to h times 6 plus h over h. And then remember, we can cancel out the h's because we are dealing with limits. So h never really equals 0, it's just approaching 0. So you get limit h is 0, 6 plus h. So you just plug in 0 into 6 plus h, and the answer should be 6. Now let's generalize what we just did. So what we just used is the limit definition actually. So this is what the definition would be in general terms. So as h approaches 0, the limit of the function with x plus h minus the function with just x over h is actually the limit definition of a derivative. And there are several ways to write this. The one I wrote above is just one way, but they all mean the same. Now, here's a bonus idea. You can actually find the equation of a tangent line with your newfound ability to derive. Okay, so we all know the point slope form of a line. So let me just write out what the formula would be, and I'll explain it. So this is point slope form right here. FC would basically be y1, and f prime, we actually haven't discussed this, but it's just the slope, it's the derivative. So for the example that we just did, this m would basically be 6. And then c is just x1. So say we're trying to find the tangent line of x squared at x equals 4. So that's a bad drawing, but please bear with me. So we can straight off just find what y1 is. You plug in 4 into x squared, you get 16. Let's keep this blank for now. This would just be 4. So in the previous example, we did it for a specific case. We did it for x equals 3. And while we have x equals 4 in this situation, we're actually going to find the general derivative for x squared, and then just use that general derivative to find what the derivative at x equals 4 would specifically be. So if that's confusing, just let me do it and it'll make much more sense. Okay, so we're going to write lim and then h goes to 0. So our y2 is x plus h. Our y1 is just x. And I'm following this right here. So then you would just have h at the bottom, and you just simplify. And again, since this is a limit, we can cancel out the h, and this h would just be 0, so it cancels out. And the limit actually equals to 2x. So whenever you want to find the m portion, this right here, you can actually use 2x to find that value, given what the x value is, of course. So for our case, x is 4, so you would do 2 times 4, and the equation would have a slope of 8. So now, just to show you that it actually works, I'm going to graph it on Desmos. So you have y equals x squared, and then what we came up with to be the tangent line. So y minus 16 equals 8 times x minus 4. So as you can see, it seems to be correct. Right there. So you have 4 comma 16 right there. So the tangent line is very much correct. And that's it for this video. Please like, comment, and subscribe, and hope to see you in the next one.